record 一下，好的，现在开始 record 了。有一个 serialization 和 linearability 的问题是吧？我忘了具体问题是什么了，静怡能重复一下吗？
哦，好的，我记得你之前好像有，可以听到我说话吗？
可以。
哦，你之前好像有一个topic 是讲，要设计一个订票系统，然后 database 要沿着它的 consistency model 是linearizability 的，然后呢，我就在想呢，嗯，我在看那本书的时候，看到他说，这个 CAP 里面的 C 其实是 linearizability，是可以 always read the latest write。但是其实这里的话，我觉得但是他解释里面呢，他解释的时候 linearizability 是，如果其中一个 read 是 latest write，那它后面的 read 都是 latest write。
对的，对的，这是 linearability 的要求。
对，是的，但是其实这里是不是还是有一个 replication lag 的？
replication 的话，这块的话就是 depends on 你 read 是不是从 master read 了。如果你所有的 competing 的话都应该从 master read 的话是没有问题的。然后那个订票的问题的话，其实你 partition 好的话，它是个单机的问题，它是一个 single， 不是说一个单机问题，但是你所有的 request 可以到一个 node 上嘛。订票的时候，你所有的 request 可以到一个 node 上。然后如果你这个node 就是你如果 node down 掉的话，可能会有一些data loss。但是如果你写的时候，就是 n+1的话，就是你写的时候同时加一份备份的话，这个 data loss 基本上就没有了，基本上概率就很低了。
I see, I see。那其实我是想，其实那个订票的话，我觉得它最 critical 的问题就是不能让已经订了的座位再被人订吧。然后，其实它这个怎么听上去是一个 serializability 的问题，而不是一个linearizability 的问题呢？
其实我觉得反而更多像一个 linearizability 的问题，因为这个 linearizability 更多是针对单个 object，就是你这种情况下的话，就是你其实想一下，它那个订票的时候，那个订票系统，如果我们看一下那个订票系统的话，它其实就是说白了是 insert 的一个 record 的那块，它主要的都是 insert record，你其实没有多个 object 操作，就是作为 user 来说是没有多个 object 操作的。然后我觉得最主要的 linearability 和 serializability 一个不同，就是 serializability 的话，很多时候它那个逻辑是有多个 object 操作的，所以它那个我感觉它那个多个 object 的话，这个多个 object 有可能不在同一台机器上。但 linearability 的话，虽然我感觉 linearability 很多时候讨论的是单个 object，但也有多个 object，但是我觉得它这个很多时候就考虑的是不是这几个 object 是分在不同的 node 上。
哦，I
嗯，
see。
所以
OK。
很多时候，我觉得最主要的区别就是linearability 就是它实际上是就是叫 read recency 嘛，就是 recent 是 read 嘛，就是你刚写的和读的是同一个东西。你刚写了以后，你读的是同一个东西。如果你写了 commit 的话，你稍后的都读的是这个同一个东西。我们可能稍后也会 cover 一下。然后我们就是说的时候还是要看语境啊。我觉得如果说如果这个东西是就是 做 partition 的时候做的比较好的话，所有你写的 related object 都在一台机器上的话，我个人觉得这个 linearability 和 serialization 差别不是很大。就是你 partition 做的比较好的话，但是如果 partition 没有做好的话，你一个 transaction involve 多个机器的话，那你那个不管是做 two phase commit 还是这个 linearability 还是什么，我感觉这个 cost 都很高。
哦，这样子，好的。
对，
哎，那
然后
它那些可以做到 linearizability 的那些 database，它是不是在 write commit 的时候都要做一下 compare and set 呢？
compare set，我记得 compare set，我想想，我记得 compare set 是和 consensus 和那个 linearability 是相互对比的。我记得是 linear read 和 write 是不需要 consensus，但是 linear compare set 是需要 consensus。 对它这个问题可能相对来说都可以最后相对比较等价的，还是对。
所以还有 linearability linearable 的
有
linearable 的
有
方向。
linearability 其实是一个非常抽象，就是它是一个抽象的概念，它有 linear read、linear write 和 linear compared set，然后 linear compared set 和 consensus 的那个 requirement 是一致的，它也和另一个就是要求几乎是相互等价的，但是它这个 linearability 其实有多个read、write 和这个 compared set。
I see，
嗯，
以及这个 linearability，还是之前那个问题啊，就是它如果不在 master node 上面 read 的话，它还是有可能会读到旧的 data，是吧？
对，它不在。你比如说，我们老是说，一直在说这个，就是 consensus 最常见的一个实践是 zookeeper，但是 zookeeper 的话是，它那个就是那个 write 是有 linearability 的，但是它 read 你如果不是从 master 上读的话，不是从它有可能会读到 stale data，所以 zookeeper 是有可能读到 stale data 的，所以它那个如果你想从这个 zookeeper 上读到最新的 data，就是guarantee read linearability 的话，你需要先 sync 一下，然后再 read。它有个 sync operation，然后再 read，或者还有一个 combine 叫 sync read 也有可能，我忘了具体是，但是你需要 sync 一下才能 read 的。
那所以是要把 read 给 block 住吗？
啊，
就是要先 block 着 read，
它block read 还是 block write？
那你要 sync 之后才能 read。
sync 可能是要 block write 的，这可能是要 block write，因为不 block write 的话，你可能读的就不是 linear 东西。snapshot isolation 不能 guarantee linearability 的，对的，
哦，对，是的，是的。
对，snapshot isolation 是不能 guarantee linearability 的。啊，哦，行，
好的，很解。嗯，
对，这边的话，反正就是我觉得一般面试不会面试这么细的，中间有很多细节啊，就是比如说你 linearability 和 serialization，我觉得面试的时候，我觉得能面到一个 CAP 或者 AC 的已经很不错了，中间有很多细节，并且这个从那个理论到实践的那个 mapping 其实也不是那么细的，就是你比如说这个 linearability 和 serialization，你 argue 一下什么时候是 linearability，什么时候是 serialization。这个中间细节其实也挺多的。你比如说你如果这个系统 guarantee linearability，你不一定 guarantee serialization，然后你系统 guarantee serialization，你不一定 guarantee linearability，这就非常理论了。我觉得这个没必要搞那么清啊，就是但是有一个
真的会
大概理解是比较重要的，对，
我一个月之前还不知道呢，我都是最近这个月在看你推荐那本书才知道呢。
对，它中间还是有很多细节的。
好的，好的，
好的，
感谢。
好的，好的。Warren 在吗？我们今天来 interview 就是 mock interview 一下，然后 Warren 也非常主动的做志愿者，然后非常感谢然后就是给大家提供一个就是 data point，就是让大家看一下就是正常的一个system design interview 是一个什么样的流程。然后我再说一下，就是如果我做 system design interview 的话，我会 evaluate 4个方面。一个就是 past project，比如说就是past project 的话，就是说比如说我现在尝试 interview Warren 的话，就是说我问一下 Warren 做过什么 past project，然后其次的话，我会尝试看 Warren 的表达能力怎么样 articulate problem，然后能不能 drive conversation，然后的话我们会考察一下 Warren 的这个 knowledge 是吧？就是这些一些常见的 database 知道不知道啊？然后比如说 serialization 是怎么回事啊？这种。然后其次最后是 problem solving，就是我给的问题能不能解决如果就是说，如果说我给的问题不能解决，但是你剩下的3个方面答得很好，我觉得没有明显的 red flag 的话，过的概率也很高。所以解决就是面试官给你的问题只是其中1/4的过程所以它其他的3/4都很重要。然后我觉得我们可以开始尝试一下 interview 了。Warren，你在吗？
能不能先把那个 doc 的那个 request access 可以给我一下吗？
对，好的，好的，我先分享一下，你用的是那个 Warren，
不是，我 send 一下。
好，你发到这块好了，好，然后然后你可以开个摄像头嘛，这样的话，我觉得我们可以讨论的时候就是多一些那个 做一些互动。对，
需要我 share screen 吗？还是？
不需要你 share screen。我们现在可能就是先问一下，你的那个 past project，就是完整的模拟一下1个小时的 system design 的面试。好，你把你的 email 发给我，我 share 给你。
我已经发了一个 request。
你发了一个 request。好，OK，let's get started. First let's talk about some project you did in the past. 一般来说 project 我喜欢问2个，就是一个是 most interesting project 或 technical challenging projects， 另一个就是technical challenge project， 另一个是 business impact 最大的 project。我知道有人喜欢问的一个问题是说，这个就是你最困难的一个 project 是什么？但是我一般不喜欢问这个，我就一般来说就是可能3个问题嘛，就是 business 影响最大的，然后 most challenging， 然后或者是你最有困难的。这块的话，我们就找一个 business most challenging， technical most challenging 好了。就是回答就是 let's please spend like maybe 5 minutes to describe a technical most challenging project you did in the past during the work. Maybe let's not include the school project. And also here 就是这块 Warren， 你可以简单介绍一下你的这个就是工作经验和这个对，然后大家有一个reference point。
Okay. I'm currently in the Uber Money team, so the payments, dealing with the payments. So my most recent projects are mostly about payments. So the most you're asking about the most difficult in tech aspect or business aspect?
Tech perspective. Let's actually answer some tech related projects. So tech perspective maybe.
Yeah. So tech perspective, I think it's last year I did some migration of the payments grant storage from the Dynamo standalone DynamoDB into the Ledger Store Gateway integration. So I think this one is relatively tech challenging. So it includes in the connection with the Denmark team about talking about the negotiation of SLA for the Ledger Store Gateway, and also how to seamlessly migrate from the Grand Store Legacy Dynamo into the new Ledger Store Gateway. So this project takes around 3 months to finish. Yeah.
So what's the main difficulty in the project?
The main difficulty, I think, is the fallback strategy for read and write, because you have to read in order from the Grand Store to make sure it's lossless. It's the most difficult point. You have to first write to the Ledger Store Gateway, then to the Grand Store, and then reverse the order to make sure that there's nothing lost during this process, and you have to write lots of validations to make sure that during this process the records are trackable. So that's the most difficult part, I think. Yeah.
Okay, so you did like dual write and then disable one write and double check like shadow write and then reverse the shadow write, something like that, right?
Yeah.
Okay, that's great. 所以我们这块谈的就是我觉得就是做个工作的话，就常见的一个 data migration 的一个过程，就是 data migration 是非常非常难的。就是我之前也做过几次，很多时候你要一个 dual write， 就是开始的时候2个 data style 同时写，然后在写 A 的同时再写 B， 但是你可能 A 是之前旧的 ，B 是新的，然后你需要就是 offline verify schema， 然后保证没有 data loss， 然后最后的，然后你再有一个 switch 是吧？有个 feature flag， 然后你 feature flag 一卡，然后就 B 就是主要的了 ，A 就是 secondary， 然后这2个都没有问题以后，你就直接写 B， 然后 A 就扔掉。这个其实做过的话就知道，这个确实要花很久的，大概要3、4个月。并且如果是这时候我一般面试官就喜欢问一个问题 ：Did you actually do it yourself or by yourself, or actually you got mentor from other engineer, or what's your role in this project?
We have some previous similar projects that's half completed, so I could check some materials from them. Mostly done by myself end to end. Got help from the staff engineers also. Yeah.
Okay, that's great. And also, how did you handle the historical data? Did you actually write a script? Did you write a job? Or how did you migrate existing historical data? Not do you write only handle the new coming data, but not historical old data?
Historical data, we set a timestamp. So some hardcode timestamp to set. Before that, we stop writing to it because the grants has a limitation of 6 days expiration time. So before the 6 days expiration time, we don't need to care about the writing anymore or modification of it. So we kill the writing to it briefly, and making it separately, it makes us easier to handle.
Oh, okay. So basically, you don't need to do the historical data migration. Yeah, you don't need to have a Python job, Airflow job to migrate like a batchly. OK, that's good.我觉得这边回答就是非常不错的，就Warren就是把这个问题阐释清楚了，并且先讲了问题，然后explain 一些 solution。当然，我觉得这块的话，我推荐你再说 deep 一点，就是这个的话，可能如果你主动去面试的话，你可能要多花点时间准备。就是把那个 technology 提一下，因为这个的话，就是你 expect 5分钟的话，你比如说可以谈一下这个，这个是首先你是自己一个人做的，还是从 design、从 implementation、从 test， 然后再 deploy 是一个人做的，还是多个人做的？然后其次的话，你可以谈一下这个 skill， 就是 skill 的 problem， 就是很多时候同一个问题不同 skill 的话是不一样的。像刚才的话，我们其实没有谈到 skill， 对吧？这个 skill 的话，如果面试官没有问的话，他可能也没有这个印象。然后谈了 skill 和这个了，然后就是这个 independence 这个以后呢，然后呢就是您可以 explain 其中一些细节，为什么要 do right 是吧？不一定所有面试官都做过 data migration 是吧？你说为什么要 do right， 然后中间可以多花点时间去描述一下，加一些 add some color to it， 这个还是很重要。我觉得但是总体来说，我觉得这个 articulation 我觉得是非常不错的，我觉得这个表达是非常不错的，没有任何问题。然后其次的话，最后一点是，我还是说就是推荐鼓励找三个 problem， 就是一个是 business 最重要的，一个是 technology 最重要的，一个是对你来说压力最大的 most challenging project， 就是可能是 urgency 很高啊，或者是那个各种原因。然后这样的话，因为这个是很重要的，就是你就是为什么这个很重要？就是你的 past project 是决定你面试的 level 和这个什么的。比如说Warren，我们聊了一下，我就知道就是你大概能独立的负责起一个 data 的 migration 是吧？但是我肯定不会要求你去设计一个 Airflow 是吧？design implement 的一个 Airflow 是吧？但是有的人的话就说他过去的 project 就是 design implement Airflow 的话，那我说这个人招过来，我就 expect 他去 design implement new Airflow。所以这个 past project 是这个虽然这个问题就5分钟，但是它实际上是决定你的 level 的。就是如果我面试的话，这个我问的问题能不能过是 yes or no， 但是你的 level 具体是什么，我可能是根据你的 past project 来的，就是我可能就 calculate 那个 evaluate 的时候是根据你 past project 和 work experience 来的，是吧？如果就是比如说我人说在这块做了一个比如说做了一个 dispatch 是吧？就 invent 了一个 new Uber dispatch system， 然后 get rid of this 什么 RTAPI 或者 dispatch existing dispatch， 然后增长了多少，然后带来多少 business impact， 那这个 level 肯定会高一点，是吧？如果是做 data migration 的话，还有一点就是即使是问 technical challenge 的，最后来说还是要落实到 business impact。即使你是 infra engineer， 比如说如果你是 infra engineer， 比如说我举个例子比如说那个我记得我们前段时间那个前年的时候有个 Go 的 engineer，Go 的 engineer 是就是从 Google 来的一个 Go 的一个发明人，我忘了是 Robert Pike 还是谁了，就是他过来 Uber 讲了一个 speech， 我忘了具体是谁了。然后他讲了一个 speech， 然后他就讲了很多 business， 他是一个非常 technical 的人，但是他讲了很多 business related， 比如说 SLA 是什么 ，SLO 什么 ，stop word 他们怎么样优化使 Go 从一个 version 到另一个 version，stop the word pause，compiler pause 减少了50%多、60%多， 他给了非常细的数字，说你看到吧，就是非常 technical 的人，他其实也 focus on business 的，像 stop the word pause 的话 ，compiler 就是 stop word garbage collection pause，它其实是非常 business 相关的，但是他讲了很多，很 focus on 那个。然后另一方面的话，如果我们看就不同的来自于不同的那个大佬来自于不同的地方讲那个 presentation，你会发现他花很多时间 focus 然后 business 上，就是 business impact。所以我觉得这块的话加点 business impact 也非常重要。但是总体来说，我觉得 articulate 是没有问题的。好的，OK，let's start interview. Warren, do you mind share your screen? So we can start.
Okay. Wait.
然后我们在这块儿就是再聊一下，就是system design 呢是非常 casual 的一个过程，就是你没必要紧张，反正就是这个准备呢是需要很多时间积累的，但是它不像 coding，就是你 coding 会不会就是很多时候一 rush 就出来了是吧？稍微一努力就出来了，但 system design 是长期积累的一个过程，如果你不会的话就不会就可以，或者是你之前做的 project 就相对比较简单，你就说一个你做过的 project， 我觉得它这个重要性就是真实性是远远大于就是你去就是仿造或伪造它那个过程的。然后就是你描述你自己做的东西，然后你对东西非常熟悉是非常非常重要的。然后另一方面的话，你没必要完成，就是所有的 system design 是没有必要完成的。就是说，像我们之前说过，就是如果你完成这部分，其实只占了你整个问题的1/4更多的时候是就比如说你过去的 project 是什么是吧？然后你问题啊，然后解释的问题啊，然后这个表达能不能 drive conversation 啊 knowledge， 然后完成问题只占1/4，所以没必要担心，就非常 casual 的一个过程，更多的是一种聊天，就是说，比如说我现在要招 Warren 到我这个组来工作的话，那我有没有就是说我有没有 confident 的说，我觉得 Warren 一上来以后，第1个月、第2个月、第3个月能做什么，前6个月能做什么，1年能做什么，2年能做什么，是这个一个过程，所以它更多是一个 casual 的 conversation。所以大家就是面 system design 的时候也尽量使自己放松一点。OK， so today let's try to design a notification system. Assume that you want to design a system for your company and support all kinds of notification. The notification including like in-app notification, like Apple or Android built-in notification, email notification, phone notification, message notification, and because that you may want to use some other third-party services like Twilio or SendGrid. SendGrid, I think, is for email. So you want to make sure you support this integration as well. And also, let's actually try to support more than one delivery method. Means that we can have at least once delivery, maybe at most once delivery, and exactly once delivery. That's actually quite important. Because LinkedIn was actually fined for a lot of millions of dollars because it's sent a promotion email for more than once in 2015 and 2014. Okay, and also a unified interface for other service to use your system. So basically, you may either handle endpoint or it could be a Kafka topic, and other service can call the notification service, call your notification service with parameters you specify. And last thing that you want to make sure your system is monitored, the health is monitored. Like I'm not talking about like Docker, like not talking about Docker CPU, memory, disk monitors. Here is more like a business oriented. It's more like a monitor, like how many notifications are sent and what's the progress, like how many notifications are queued, and for each like each vendor and each like email, let's say we have 100 email notification stuck there. So if it's stuck for a long time, you want to be able to visualize it, and so create a visualization for the how many notifications are sent in progress and queue. Basically, that's the requirement.
Let's first begin. Start with the business use case. And then I will go to the constraints. Then I will go to the API design and the and finally, some data schema if we have time. So for business use cases, I want to first line out the MVP features that we have. So the MVP could be delivery of notifications for variables, various of receivers. The receivers could be apps, email, or phone, or SMS. And the delivery support different of mode, like at least once, at most once, and I think there's also a bonus that we could good to have, and is that delivery support for exactly once, and there are non-goals.
Yeah, so I'm curious, what do you think is difference between at least once, at most once, and exactly once?
At least once, I think at least once could be achieved by retry queues, and it requires durability. And at most once means that you could fail and forget. Under this case, it doesn't need to go through a retry queue. Exactly once means that you have to, and the delivery also requires differently. For example, the decoupling of sender and the receiver. If you use Kafka, you should also use the corresponding at least once, at most once, or exactly once model. If the previous things like this, and in the requester side, namely the client side, at most once or exactly once also means that you need to make a request be idempotent. You need to fill out early, maybe on the load balancer stage or earlier, make a filter to filter out duplicate submissions early, and make extra processing later, maybe. Is that right?
Oh, so actually the concept here, exactly once, is different from Kafka exactly once. The concept here is exactly once means that if I send a request, I expect you receive email exactly once. But that's difficult because it's actually two system transaction. It's like a transaction across two systems, right? So for example, because we're most likely going to be built this as a web service, and if I request your service, send an email to me, right? And your email you're going to call a third-party API, and then if third-party API timeout for whatever reason, no response, you don't really know if the email is sent or not. So yeah, so if we want to have very strong control or exactly once, it requires like a two-phase commit, something like that. There is a I think there is an architecture, very old architecture for it. Transaction X transaction or something, but it's a difficult. So let's skip that part. It's fairly difficult, and if depends on if you have some system you cannot control. Then like if the integration third-party system you cannot control, then it's basically impossible. Okay.
And
That's fair. That's fair as a leave it as a bonus. Yes.
And bonus also includes MVP also includes push and pull model. For active subscribers and idle subscribers. For example, when the subscribers are active, you need to push them out. But some subscribers, for example, you have apps or iOS that's closed or didn't receive any notifications when you open your iOS or reopen the app. Maybe you should receive some background or some apps that's running some background threads. They would pull the notification service, and you will receive multiple notifications when you open your iPhone, things like that. So that's one of the MVP also. And bonus includes also
So by push and pull model here, I understand what's the active and idle subscriber. By push and pull model here, what are you referring to?
it means that beside pushing, every time a sender send out, the requester could also do some kind of YAP or gRPC call directly to retrieve the message from the data store, maybe.
Oh, okay, I see.
And the bonus could also be recurring notification, or it's especially useful for the emails and SMS and the scheduled notification. And for non-goals, I think the first one is about latency for delivering the message notifications. We don't require delivering of the notifications, every message to be immediate. Some of the notifications are high priority. Some of them are not. For low priority messages, for example, Twitter messages, we often see they are delivered several Twitter notifications in the app. We often see it delivered several hours later. We don't need to maintain the order of delivery or maintain the order of notifications. And for the performance, for the constraints, I think we need high availability because we want the notification. We could send a request to notifying our subscribers anytime we want. We don't want to. Sometimes we find it impossible to send out notifications, especially very important notifications, and high scalability.
Actually, you haven't asked me the skill. So let's assume that we are designing the notification for Facebook. So you have
oh, okay. So
200 million active user and maybe five notification per day.
Let's get some. Would you mind to repeat?
Yeah, let's assume that's a notification for system for Facebook. So you have 200 million active user per day, and each user has 5 notifications in average. 200 million. You're missing 0. Yeah, 200 million active user and then per day, and you have 5 notifications per day per user.
5 minutes.
five notification per user per day.
Okay. It means that if these are all push methods, that means that 200 million multiplied by 5 notifications and divided by 24 hours, 6 minutes, 6 seconds. Um,
这块有个快速的算法，就是除以10的那个5次方，10的5次方，对，快速算法是除以10的5次方，所以它这块其实是10的9次方除以10的5次方是10的4次方。
OK，
对，就是这个，就是但这样的话可以省点时间，这样的话，比如说可以省半分钟时间，还是很重要的。对。并且你可能还要，就是你 pick request 可能还要乘个5嘛，是吧？对，你 pick 乘个3乘个5很正常。OK， 只要估计出数量级就可以了，不需要那么细的。对 ，OK，this looks good to me.
And we want, let me go with this. So it means that the reading cannot be within one machine. It could easily exceed the limitation of the one host, and we need either sharding or need horizontal scalability. So with that, we have also we need high availability, high scalability, and flexibility. Means that we need to support different senders and different receivers. Senders could varies from some like different topics. I wonder how many topics in total do we have? Different kinds of topics in total do we have?
What topic you're going to create it based on?
Would you mind to repeat?
So how are you going to create topic? What topics are you going to create it based on?
I'm going to create topic based on topic name and the surface type, and with topic and some other topic metadata information, and the message itself it want to send. The message itself want to send may include and one thing non-goal is that we will just send message, no images. Is that allowable?
Yeah, so I think in here, if you're going to send emails, then you're going to have image, right?
So image is a bonus.
Image, we can add it as a bonus, because if you're going to send email, you have image there, and you may have possibly video, but most likely you're going to be a HTML file, like a multimedia.
Okay.
Yeah.
So maybe some message IDs to refer from. Messages, for example, if you embed some kind of videos or some kind of images, we could send a message like HTML object body directly, embedded it with the video ID or the image ID, and the render could basically load this kind of thing later in the client side. So the message itself is a pure text version. So this is a format of the topic itself, and of course topic ID. I wonder how many topics, namely different kinds of notifications, that the notification system could support. Do you think?
Yeah, I think we need at least one topic for SMS, like message. We need one topic maybe for email, and another message, another topic for um, phone, maybe. I think phone is another one. Then the last one is in-app. For phone one, you probably once you deal with phone, you probably want to pipe in pre-recorded audio. Let's keep it simple, just pre-recorded audio, something like that.
Oh, okay. And high availability, high scalability, flexibility, and what other things? Let's keep it here.
Yeah, I think this is good. Let's actually go to the API design architecture or database. I think it looks good so far. So
okay. API design. Oh. API design is like we have let's design create topic with a topic topic ID with a topic name, and as we have the topic here, we need to surface type metadata.
So what's the topic here you are referring to? Is this a Kafka topic you're going to?
I think it's a notification topic that we are trying to create. So
Could you give an example?
For example, notification for example, app like Twitter wants to send its notification, and it wants to send a new version of the topic, not feeds topic, but some kinds of ads campaign topic into the notification service. Then under this case, it will add a topic name like ads campaign ID 1234, and the service type is in-app, and some metadata like priority, like this kind of topic should be sent like security token, security metadata, things like that. With this kind of notification sent.
I see. So
yeah.
you're referring to more like a notification template, right? It's like an email template. Okay.
Some kind of this. So you could store this kind of things in one either metadata store or the topic store. And beside the create topic, I think there's a send topic mode. And subscribe topic ID mode.
So can you give me some example? Like send, I understand what's send, but what's the value for send mode?
So the topic ID is a corresponding topic you want to send the template, and the send mode is what we have mentioned is some kind of at least once, at most once.
I see.
Exactly once. And the sub mode is some kind of different. I think the submode is kind of, we want different priority for the subscription. For example, some kind of SMS, we want it to be delivered directly. And some of them we don't care about the latency of it. So maybe I haven't thought too much about the subscription mode that we could have. Let's put it here. But basically, what I could think is these are all the three APIs that we could use for notification system.
Okay, so I'm little confused. If I'm understanding right, so for your part, you have topic, and topic have subscribers.
Yes. Yeah.
And so basically, when you send topic, you just need to send subscribers, and you can use subscriber. You can have subscribe API to manipulate subscribers. Is that what you mean?
Yes. So the different so different devices will always listen to the APIs. So it doesn't mean that the subscribers, the different APIs could call the subscribe API directly to make a registration in the notification system. So the notification will send to them. And for example, you are making a phone call. The phone call, the sender will send to the notification system instead of the phone call. The phone service will send a request directly. The sender will serve as an adapter to adapt to all different kinds of services.
Yeah. So could you please explain how your system going to model the following scenario, like services and SMS to user one, service B send email to user two, and services and phone calls to user two?
So this kind of thing is like, so it's in fact included in the architecture below. I would explain about this.
Okay, sounds good.
So this is a client, and the client goes through the load balancer. And briefly speaking, client go to a load balancer, and also there's kind of metadata storage for storing the topic and other metadatas. And meanwhile, after the load balancer, there's kind of temp storage to store the messages to send. And with this, metadata surface and the temp storage surface, and with this, temp storage surface will go to the sender. Sender with the adapter to different SMS, email, phone, things like that. So in fact, it's an adapter that goes to all different kinds of devices in the last. Does that sound good?
Yeah. So yeah, I see. The adapter here is a third-party integration. Basically, just an interface.
Yeah.
Okay, makes sense.
So I'll move it here.
So Yeah, let's actually, I think this looks good. I understand. So basically you send, basically you're going to have some metadata information and record some metadata, and then message going to store in another storage, like a temporary storage message service or message storage service, something like that. Then you go to the sender, and then here you may call third-party API. So that's why you have adapter here. And then at the end, like notify user. And also, do you want to keep client waiting during this process, or how do you going to respond to the client?
Response to the client request?
Yeah, so you have a client request. How do you handle it? Like, I ask you to send a phone call. Yeah.
Okay, so the client is in fact the one who send out a request. For example, Trump send a Twitter, to send a tweet. Here, I think Trump is the client, and the sender go all the way to different SMS. It means that all the followers of Trump would receive the SMS or the tweets, in-app tweets. So this client is in fact the for example, Trump and the followers. So
yeah. So my question is, what's from client perspective, what's the life cycle looks like?
The client's respective, the client has some kind of okay, the client has some kind of reverse proxy. It means that it sends a request to the server, and the request is encrypted. And with the reverse proxy, they could decrypt this kind of HTTPS request, and also to normalize it as a server request to send it for internal server use, and also the local cache, because it just sends the topic and doesn't know what's the corresponding topic name and the metadata, other metadata could be. So it will query the metadata service. And to make it as a full metadata JSON topic JSON format, and also it would call a local disk to emit the metrics, as we have mentioned in the requirement above, that we need a real-time system dashboard to show the process about how many notifications are sent and progress. So this is the enter gate of this. So we'll emit the metrics for the client side, and also some logs to store it. And in the load balancer.
Sorry, I don't think it's a good idea to actually display dashboard on logs and matrix. 我这块说一下，这个就是一个 yellow flag 了，就是你一般来说是不会把 logs 和 matrix 作为 dashboard 的。为什么呢？因为 dashboard 的 data 讲究的是不丢，就是你 durability 要保证的。但是现在所有的 logs，就是你支持 logs service， 不管是 Grafana 还是一些其他的支持 log service 比如说 log DNA 这种 third party， 它 handle 都是非常 massive data， 所以它是允许一些 data loss。它很多时候用的是那种，如果我记得是上周讲的话，它用的是 log structure merge tree。它很多时候就是就是说 log structure merge tree， 并且它是不 guarantee durability 的。所以如果你用 logs 来 track dashboard 的话，你很有可能会丢 data。
OK， 那我们需要一个 extra database 吧？
对，所以这块就是当你看到一个 real time dashboard 和当你看到一个 dashboard 的时候，第一件想的事儿，其实直观想的就是怎么样用Kafka 和 Flink。OK。Kafka Flink，这个的话就相当于是你想 Kafka 是提供 replication 和 durability 的 ，Kafka 是有 durability guarantee 的，因为它提供 replication 和那个partition 是吧？它 scale 同时也提供 durability， 所以它提供 scalability 和 durability。Flink 可以在 Kafka 上进行一些简单的一个 接口运算是吧？然后你可以有个 rolling window，所以这个它提供 natively 提供一个 natively 提供一个那个 dashboard 的 support。
Okay. So I'll not push the logs and metrics here for monitoring. Instead, after the load balancer is for the authorization, authentication and authorization.
Yeah, so I think I'm lost here. I think all my request is that all the request is actually internal service. It's like you build a client tool, you build a tool for all your company's service. So all your client is actually validated service. For example, if you're looking at the example here I give is service A send message to user one, service B, and all this is service let's say you design this for Facebook. So all the ABC here is Facebook internal service.
Okay, so the client is here is in fact all internal services, so you don't need authorizations.
Right. You don't need authorization or authentication.
Okay. So these requests go to three different ways. It first go to the metadata service to retrieve a topic, then go to a temp storage service to store data for durability, so that idle subscribers could get this data when they are active. And the third thing is that for monitoring, it also goes to the Kafka and the Flink for the monitoring. I'm not so familiar with the Flink though. For the temp storage service, we could make it as because it should be scalable. So the temp storage service, we could make it as a key value database to support the high read and write. So we could choose a DynamoDB, and for senders, we could easily make it as a different kind scaled WebSocket service, and adapter as a router. Two different kinds of devices. So if there's not enough senders, we could add scalable number of workers for the senders, and because the sender is some kind of stateless, we don't need to worry about this part, and same goes to the adapters.
So you want to do it asynchronously, like worker pool asynchronous mode, right?
Yes.
Okay. You want to emphasize this keyword like asynchronously for separate concern, like separate concern asynchronously. Yeah, some keywords like that.
If so, the asynchronously. So and asynchronously. Okay.
Yeah, just async is fine. Async, everyone understand async is asynchronous.
Could I go to the data schema to draw out the schema of temp storage service?
Sounds good. I also have some lifecycle question about the, what's the lifecycle for client request and what's the lifecycle design for notification.
Oh, there's one more about the retry queue. Retry service, or retry queue or retry service. Because we have at least once this kind of requirements. And what's the question? Sorry.
Yeah, so I want to, once you finish out the design, I do want to, spend 5 minutes explain the life cycle for a message and a life cycle for a notification and life cycle for a client request.
The life cycle for client request is.
Yeah, so let me write an example here. For example, I'm a client, right? I'm a service A. Service A. I want to send as a message to user one, and then what's a different step? For example, first step, I'm going to call your API with metadata and message. Then service two, step two, what you're going to respond.
Okay. So call my API is kind of like call send and topic ID and with at least once. Under this case, with the model. Under this case, the first we will go through the client. The client will decrypt. Client will do some pre-processing. And the load balancer and call metadata service to get topic object, maybe JSON. And the third one is go to the temp storage service. Store the message. And when the message and go to the sender, send the message. If sender go to a retry service, and when the message to this is the life cycle, and
So here I have a question. When do I know my message is sent? And when do I know my message is received by you?
So
that's a two different question, right? When do I know my message is sent? When do I know my message is recorded by you?
I know my message is recorded when I store it into a temp storage service.
Okay.
I know the message is sent once step 7 got response from the subscriber directly saying that, hey, I have received your notification message. So that's the thing. So in the sender here, we also send Kafka topic to Kafka service for monitoring. Kafka Flink service.
Okay, so that you want to event stream the lifecycle notification. That's fine. My question is that as a client, am I going to wait for the 2 minutes for you to send notification and waiting the request that they have a request hanging?
As a client, you just send okay. As a client, there are three stages. So the first stage, I think, it's pending. namely the request has not been accepted by the notification system or notification service. The other thing is sending, namely the message has been stored into the temp storage service, but the sender has not yet sent out all the notifications to all the subscribers. So the third one is completed, means that the sender has sent out all the messages that should be sent out, and it's completed. And if there's some exceptions, then it could be also kind of partial completed. That's what I could think of. So there could be some status code in the response, I think, to indicate that which step are we stuck in, or have we gone through the task completed.
Okay, yeah, that makes sense. So you're going to notify your client, right? So for example, when you're going to notify your client, it's pending, when it's sending, and when it's complete or failed. Let's say, let's actually add a field here just for completeness.
Okay. So call your API. Under this case, this is pending, is it?
Yeah, that's in more like in pending state and reasonable.
And temp storage service, if a storage goes successfully, then it becomes sending, or
that's right.
failed, or the storage failed to be stored. And here sender goes to the sending. This is sending. Adapter and SMS, email.
Yeah, so in this case, you actually want to, I think my question is, in this case, you actually want to return a receipt at step 5, right? After you store the message, you want to return to your client, say, the message is sending, and then, you know, you give your client a receipt ID, and your client can ask you later, like, what's the current status of the notification? Like,
Okay.
they can, so that's my question. You don't want to hold this request forever.
Oh, you mean that? You mean that? But you and client is like. Oh, okay.
So yeah, so basically, when you after step 5, we can actually start a new page. Let's actually start a new page for this one. Okay, so after step 5, here you should return to client. Say you return to client with a receipt, and client can pull the receipt and to see what's the completed status, to check the status.
Okay.
Right.
May I know why? What's the reason that we couldn't give immediate feedback in the pending stage?
Oh, you cannot give in pending state because you haven't stored the message. And if the worker actually failed, if your server actually failed, you don't store anything. You just you know, fail to response.
假如它是 stuck 在 pending stage for a long time, for example, next time you have the request ID, and 你根据这个 request ID 去查它的时候，它还是在 pending stage，那就说明它还没有被 sent out。
你不能在 pending state 的时候返回，因为 pending state 的时候你只在做 pre-processing， 你在那个就是那个机器上做 pre-processing， 你就是
the client could close the socket, this kind of thing.
Your server can crash.
Okay.
Right. So 所以就像做咖啡一样，说你现在要 send 一个 notification， 你在什么时候返回说啊，我这个我在做了，我 working on it， 就是你再把 metadata 存下来，并且这个就是你这个我这块可能这个你打这个可能是包含了 metadata storage， 如果是 new topic 的话，可能是要包含是吧 ？new topic including topic storage 是吧？对。然后就像你做咖啡一样，就说你现在要求做一个咖啡，你什么时候才能说 OK 我收到了？你必须把做咖啡的单子打出来以后，对应到我们这个里面，是你什么时候可以跟 client 说我收到了，请稍等，是你要把整个 message 存到 database 的时候。
OK。
所以我觉得这块这个很好，这个其实这块这个其实是 database status transition， 这个是很好的，就是你实际上把它存到 database 的时候，就变成了就是 pending， pending 可能需要做一些额外处理嘛。sending 的时候就表示我在尝试 send 了，如果没有的话，可能有另一个 thread 来去重新 send， 是吧？所以你这块以后你不能让 client 等好几分钟去 send notification， 你一定是先把 message 存下来，把 metadata 存下来以后，先把它变成 pending state， 然后有一个 asynchronous thread 说，哎，我把这个 pending 变成 sending， 然后做 send 的这个动作是吧？但是你这会儿就是 data 存下来的时候，你就要返回给 client， 你就给他一个 receipt 说这是你做咖啡的凭证是吧？你过段时间再问我咖啡怎么样了。
OK。
因为你这个，我们说为什么要这么做，就是如果你不这么做的话，你的 availability 很低很低。你一个 request 要占2分钟时间，你1000个 request 你要占2000个 socket 的2分钟时间，是吧？1秒钟就要占2000个 socket 2分钟时间，这个就你的 availability 几乎为0了就。
就意思是就是到 step 5我就可以直接返回给那个 client， 让他 close the socket， 然后他之后什么时间来查都可以，是这个意思。
对，他就用 receipt 就可以查他那个 notification status。
OK。
就像这个就是我们之前谈论的 worker queue 嘛，就是 worker queue 做咖啡，就说白了这个做咖啡模式，你不是说他 order 了以后，他把咖啡整个 serve 过来你才返回，你就 order 了以后给一个 receipt 就可以了。然后咖啡是在用 worker 去做嘛，就是可能这个 worker 数量也是 scalable 的 worker， 对吧
？OK。Should we go to the data scheme?
Yeah, let's go to the data scheme. I think it looks fine so far. Let's actually finish the data scheme. That's probably the last session for this one.
The data schema should be the temp storage surface. So what should I? Temp storage surface includes the message ID, topic ID, and temp storage surface status.
Shouldn't status be metadata, not part of the message?
Yeah. The status should be
you have a metadata table, right? It shouldn't be part of message, right? Because
for example, several tweets. You have different messages, different message ID, but the same topic ID, is it?
Different message ID, same topic ID, yeah. But I'm saying the status shouldn't be part of this table.
Under this case, different message ID means different status. If I store it in the metadata table, that means
if you have different message ID, it will be different row in metadata table, right?
could be.
Yeah, let's put that as a separate part. Let's look at the rest part.
Message ID, topic ID, status, this kind of another table.
So you have two services, right? This is similar to Slack. If you remember the Slack discussion we have May 26, I think in May 26. In Slack, you actually have a message. So you have a message storage service to store the message, but you also have a different service to store the message delivery part. So you have a metadata service to store the message delivery part.
Okay. And for this one, message ID, topic ID, what others should I do? Mode. Sender mode.
Let me copy an example so we can fill the example here maybe.
Sure.
Yeah, so this is a DynamoDB for message storage service in Slack, and we can fill in here maybe.
So I think the key is message ID. The partition key is a message ID. Yeah. And sort key could be sort key. Sort key could be timestamp, and this message ID and sender ID. ID, sender mode. Surface type. With the sender ID. Does that make sense?
Yeah, I think this makes sense.
So this is basically the schema.
Yeah, I think this looks good. Let's actually look at metadata.
Metadata.
Yeah, you do have metadata, right? You want to control lifecycle notification and also.
Metadata is like because the metadata is not so large. The metadata service has message ID. I think metadata could be stored in SQL directly, is it?
Yeah, so that's what I'm thinking as well. You need transaction, right?
Yeah. So under this case, there's no, I think that's not too much to store. Message ID status. Status. What others? Metadata.
I think I would say send mode. Send mode and service type should be metadata here.
Oh, okay.
Right? It's more like part of the lifecycle management for the message. So think about metadata as the lifecycle management for the message or for the notification or for client service, right? In that case, message storage service, as you mentioned, it's temporary storage service. It's more like a key value lookup. So it's just give me a message ID, give me the message, right? And here you may want to also have some receiver ID, right? Who is a receiver?
Oh, okay.
And then what's status and maybe some timestamp field. Sorry, some timestamp field for update or something like that. So you know which message has been stuck at with what time for how long.
Yes.
Right. So because it's also a SQL database, so you can enforce transaction here. So you can make sure all the message is sent at the end.
Yes.
Okay, so one last question. Can we actually spend 3 minutes to describe a life cycle for the notification? From a notification perspective, let's try to describe what's the life cycle for notification looks like.
The life cycle for notification. What's the difference between the life? Here's the life cycle for the client.
Because it's different, right? The life cycle notification start with the notification creation. You can so 当你们思考这个问题的时候，我一般喜欢思考一个问题，就是这个里面其实很多时候是个有限状态机嘛 ，finance state machine。这里面其实有2个比较重要的，其实有3个比较重要的 finance state machine。第一个是 a particular client request 是一个 finance state machine，我们之前花了几步照出来了，我觉得挺好的，没有什么问题。还有一个是一个 notification。就是备赛 notification 是一个 finance state machine， 它 start 是它从哪里 start 是从 creation 开始 start， 从哪里 finish 是从 notification send finish。还有一个 finance state machine 是你整个这个 server 的这个就是你 server 这块是一个 finance state machine 是吧？你包含你怎么样 track 啊什么的，这个是个 finance state machine。但是这块的话，因为这个 server 这个 finance state machine 的话，其实很多时候被这个 notification finance state machine 和这个 client request finance state machine 就是给大部分覆盖了，但是这个但是你思考的时候也可以思考一下，就是这个里面重要的 entity 的话，它的 life cycle 有没有把它就是 picture 出来。如果没有 picture 出来的话，是不是有哪个地方我没有讲，就是想到
？A life cycle for
notification, a particular notification。你想。我是 service A， 我 send 一个 notification 给你，从我自己的角度 life cycle 我看到了，就是在第几步返回我是 pending， 在第几步返回我是 sending， 在几步返回我是 complete。
OK。
但作为 notification 的话，其实我们并没有画出来。
就是说他画出来从 SMS 到 email， 然后返回给他的过程吗？还是
不是？就是它每一个 notification 应该是不一样的，但是其实有相似性的。比如说，我给你举个例子啊，这块我们可能就不那么细的聊了。但是如果你去最后的话，就比如说有个例子在下面是吧？第一步是不是比如说要 send email 是 email creation 是吧 ？email creation 里面包含几步呢？包含首先是 allocate email template 早见 find email template。
OK，
对吧？然后再什么 find
different methods。
对
OK。
是不是先找见 email template， 然后再找见 receiver 是吧？然后再找见这个 sender 是吧？就是把一些 metadata fill in 是吧 ？fill in metadata 是吧 ？fill in metadata 比如说 who 是sender 是谁 ，receiver 是谁？因为你 template 里面应该没有，对吧 ？receiver 是谁？然后等等的 metadata， 然后呢，你可能还有一些自己的那个，比如说你还有 experience control 是吧？你不同的 user 可能 experimental control 是吧？你不同的 user 可能收到的 email 是不一样的，是吧？当你 create 的时候 ，create 完了以后，是吧？你 install 完了以后呢，你 set email status to pending 是吧？然后我们可以这个叫 notification service 叫 NS 好了 ，NS set NS send email and then set email status to sending 是吧？然后 NS 就可以不停的 pull 这个 email server 的这个，不管是你是比如说你要是用 SendGrid 啊，还是用这个 Twilio， 你可以去 pull 它，然后问它这个 status 怎么样 ，sending status。然后如果 fail 的话，再重复什么步骤？如果成功的话，重复什么步骤？这样子。
OK，
是啊，好的。I think that's it. 我最后你有什么问 ？Do you have a further question? Do you think which part you did good and which part you didn't do well?
我觉得最后那个 schema 设计有点糊。就是想问一下，那个 exactly once 和那个 at most once 那个是一般来说要注意一点什么？因为我好像 at most once 我还没有太想清楚，是不是不只是不需要 retry Q 就行了，还是
at most once 是这样子吧？就是你要 guarantee， 如果以我们下面的话，你要 guarantee 第5步 finish step 5 finish。如果 step 5没有 finish 的话，你的 system 都不会去 try 它。
OK，got it。
对吧？就是你有可能 step 5不 finish， 因为在 distribute system every single step can fail。如果你 step 5没有 finish， 你的 message 都没有 store 下来。所以 at most once 就是你 step 5 finish， 那你就 forget 了，就不会去看那个 receipt 了。
就是那个 at least once 就是你隔一段时间去看一下那个 received， 就相当于 retry Q 或者其他 surface 去看这个receipt， 看它有没有，如果还是没有 finish 的话，然后就 retry 这样子，就是
对
OK。
对，说 at least once 就是有点像你整个 lifecycle， 就是你从 step 1到 step 9，这块你画的 step 1到 step 9，它会不停的重复，直到你 send act 了。
OK。
但是 at most once 就是 step 5 finish 就 call it down，client 就不 care 了。
OK。
对吧？你还有什么就是问题？我可以就是你回答一下自己的想法、感受什么的，我们可以简单花2分钟讨论一下。
感觉这个 message system 其实跟那个 Slack 蛮像的，就是那个 Slack 的 sub question 感觉是。
对，是的，它就是一个说白了还是讨论一些就是我们之前讨论过的一些philosophy。Separate concern asynchronous processing，worker pool， 然后 API 设计的时候就是有一些细节也有一些比较细小的 knowledge， 比如说你怎么样做一个 dashboard 可能用 Kafka 做成 event driven 的，说的都是 event driven 的，然后用 Kafka 叫 Flink 做一个 dashboard， 有一些细节，然后这个重点还是在这个 data schema 和这个就是这个 architecture 这块，我觉得这块答的其实还可以的啊。
还有那个 Kafka 的那个，在这里就是 Kafka Flink 是不是要在2个 place 去取它的值？就是在 client side 它那个要 send 一个 Kafka topic， 然后在 sender side 再 send 一个 Kafka topic。然后在那个 adapter side 再 send 一个，直到它 ACK， 然后再 send 一个，是这样子吗？
我这块一直觉得这个 adapter 这块有点 confusing， 这个 sender 和 SMS 我都可以理解 ，adapter 这块一直有点 confusing， 然后说 router 但是 router 在 distribute system 中是一个非常 low level 的，就是你和这个其他 service 都不在一个 level 的，所以这个其实你都是就是在 distribute system 中是没有 router 这个概念的，所以我有点糊涂。这个 router 指啥？但我当时没有说，就是 router adapter 其实没有这个的。这个 Kafka message 呢，其实所有的 Kafka 呢，都是在这个假设你设计的整个叫 notification service 的话，整个 Kafka 就是这个 status update， 就是你可以这么认为，是只有在这个notification 有 status update 的时候，你 send 一个
Kafka。OK。
就比如说你这个你刚 create， 对你刚 create 了一个notification， 就是你这个 notification 不是在 pending state， 你有一个 Kafka 对吧？有 Kafka message， 然后你 notification 变成 sending state， 你有个 Kafka message， 然后 notification 变成 complete state， 你 send 了一个 Kafka knowledge， Kafka message， 然后那个 Flink 把它就是有点像做 SQL 一样集合一下。rolling window 啊 ，SQL 一下集合一下，然后你就知道这个具体的 dashboard 的情况。这是 event driven 的一个设计思路嘛。好的，然后Warren， 你还有什么额外的问题吗？就是这个设计
谢谢 Scott。
好，我们问一下大家有没有什么问题？就是这块设计的话，我们大家就是有什么问题吗？在这块，在这个过程中。
我有个小问题，那个第5步为什么是一个 temp storage service 而不是一个 permanent 的 storage？
因为我刚想的时候，因为它那个 notification 的那个 system message store 不用很长时间，就是我把它取成一个 temp storage service for durability。
那你之后怎么取状态呢？假如说我发了个 message， 我1个月之后去 check， 用这个 receipt ID 或 checking ID，
就是
想看一下 status， 结果
你要把它那个 offload 到 cold storage 或者怎么样，我是这样想的。因为 notification 你不会 check 一个月之前的东西，就是你要 check 的话，肯定是 Kafka check。
不一定哦，不一定哦。所以这块我觉得我推荐你把它变成 message storage service， 在任何 system design 的时候，就是基本上我觉得 Post 非常好，基本上没有人说叫 time 什么什么，基本上没有叫 time， 你可以说它1年后 expire， 但是不会叫它 time 什么什么，就是基本上会 keep it forever almost。
对，而且一般你说 temp storage， 一般最多就是 Redis 才可以这么说。
cache 有点像。
所谓的 database 这种都不能称为 temp storage， 这个概念会非常 confuse。
OK。
另外有一个问题是那个 retry 那一块，我不知道你是在 Uber 还是在哪家公司，就说 retry Kafka 本身现在可以提供 retry，但是你说的 retry 我没有听明白，你好像是用另外一个 topic 来说 retry， 对吗？就说一个 message 发第1遍不成功，第2遍也不成功，第3遍不成功，假如说你想 retry 4次，第4遍就这个后面的几遍你是怎么做的？
第1遍不成功，就我没有太明白意思。
就是我没有太明白你的 retry， 就说是不是真的需要个 retry service？Kafka 本身，
放一个 retry queue 里面卷就行了，是这意思吗？
对 ，Uber 的 Kafka 是自带的 retry 的功能，它会自动你自己 configure，就是说 retry 5次，每次间隔1分钟就可以了，什么都不用管了。所以会简化你的 design， 你就没有 retry service 这个说法，它会自动 redeliver 这个 message 给你，你重新
可以把它改成 retry queue 之类的，是吗？
有一个叫 dead letter queue 啊
，DLQ 是吗？
这个对我跟 Kafka team 打交道非常多 ，Kafka team 那个有好多中国人，他们那个是这样的，我不知道业界怎么样，至少 Uber 已经把 Kafka 改成了，就是说你的第2 queue、你 retry queue、你的这个 main queue， 大家都可以通过 config 来控制，所以用起来还挺方便的。
对，这个我刚搜了一下，就是 dead letter queue 呢就是它不仅在 Kafka 有，好像在 Amazon Single Queue Service 和 Active Message Queue 和那个就是 Message Queue 各种 Message Queue 服务里面 Rapid MQ 都有实践，所以这个确实是有。
对，基本上所有的。
比如说 payment side 的话，
需要有 第2 queue。
比如说 payment side 的话，它那个 retry 它会有一定的 retry logic， 就是不是简单的就是用 retry queue， 就我们有一个 retry surface， 就是你还要加点 business logic， 这是我们的情况，我不太清楚，反正
你这个也是可以的呀。如果你就是在用 DB 在 DB 里来做的话，其实你这个是完全是可以的，没有问题。而且即便是用 Kafka 这个 retry 或者 retry queue， 你也可以加这种 logic 都可以的。
payment 的情况稍微特殊一点，因为 payment 你总是要 process 嘛，不 process 要丢钱。payment 的情况可能稍微特殊一点 ，retry 的这个要求更多一点，它那个不是还有一些好多额外的requirement。
OK，我回去看一下，我就其实没有太考虑到。对，
好，大家有什么额外的问题吗？还有额外讨论的项目？
那个 adapter 是什么概念？
adapter 就是 different adapter to different router could be embedded in the sender as well。对，就是刚才Scott 说，就 adapter 比较 low level 的 idea 那个 conception，就是
我还是没明白这块是什么。
我觉得应该 remove 掉，这个真的是非常 confusing，问谁都非常 confusing。
建议不要放里面，越简单，因为你已经放了9步了。对，我也做过很多 level 的东西，但我很少听说最后放个 adapter 的概念。
OK。
然后有人问说，不熟悉 Kafka 的话，这个部分的功能怎么样实现比较好？是不是用更 generic 的方式 ？Kafka 或 Message Queue 吧，这2个中的一个。我觉得这块 adapter 其实更多是个 interface 的感觉，是吧？就是那个 interface 的那种感觉。但是你后面说了个 router， 我觉得这个 router 感觉又好像到物理层 router， 所以比较 confusing， 我觉得没有必要提这个。
对，我还有个问题是那个 status transition partial 的 completed 这是个什么概念？
就是你 notification send 到一半被物理中断了这样子。
这个
可能是 internal server error code 的这种感觉。
这个不叫 failed 吗？为什么叫 partial completed 呢？
因为你会有一定的 part chunk，比如说这一个 chunk 这一个 host 的东西全部已经散的这样子，或者怎么样？
不好意思，你是做这个底层网络的吗？还是什么？因为我的想法好像
就是比如说我这个group 的notification 我已经全部 send 完了，但是另外一个 group 就没有 send 完这样子。我是这样想的。
这个 group 就是一个比较有点这个地方是有点我觉得值得推敲的地方。这个状态我觉得非常奇怪。你说 group 是，比如说我一下子发10条消息，我只发了3条，还7条没发吗？但是我觉得你 track 是一条一条的 message 的 track，而不是一个 group 在 track， 对吗？如果是的话，这个状态是非常奇怪的。这个状态的增加状态会导致很多复杂度，而且你这个状态没法解释的不是很清楚。
OK，这我可以。
不好意思，我说话都比较直接，因为我
觉得可以
做很多年面试，对我来说我确实不是很肯定。
我这边跟你赞同，我觉得他当时提的时候，我有相同的问题，但我想的可能是个 batch sent 我没有就是感觉时间问题就没有细究，但是我赞同这个观点，我觉得这个 partial complete 其实非常 confusing。我觉得我觉得下次我找你来面试我好了。
不用，那你这种大牛我
没有，我觉得理解很深入，我觉得我找你来面试我好了，要找不见 candidates 的话。
我做面试官不行，还是得你来。
不用客气。我感觉问的问题都非常深刻。好，大家还有什么额外的问题吗？今天就到这儿吧。非常感谢Warren 做 candidates， 也非常感谢 Paul 问了一些很不错的问题。我觉得今天这个问题还是挺有趣的，就是看整个一个 life cycle 问的问题，然后非常感谢大家。我们到时候下周也采用这个格式，然后尽量如果有人就感兴趣做 candidates 面试的话，联系我。没有的话，我自己做 candidates 也可以。非常感谢大家今天就到这儿为止吧，谢谢大家。
好，谢谢 Scott。
谢谢。